Welcome back, guys. Today we're going to be talking about the blocking queue interface. So guys, the blocking queue interface, first of all, it's a specialized form of a queue, just like a priority queue and other forms of a queue, except that this particular kind is actually applicable in situations where you're dealing with multiple threats and you want to have threat safety in place. So as we go on with the tutorial, you will see, guys, that blocking queue interface, blocking queue implementation classes are threat safe. So concurrency, guys, for some of you who might know, it's actually nothing but multiple thread, which is termed multi-threading in Java. I may not go into the details of multi-threading, but I hope as we go on with this tutorial, we might touch some of the aspect of multi-threading and thread safety in Java language or Java applications. So from Oracle, guys, a blocking queue is defined as a queue that additionally supports operations that wait for the queue to become empty when retrieving elements, and as well as waiting for space to become available in the queue before storing elements. So what this means is that the way a blocking queue operates is that, especially if you are working on a bounded blocking queue, if the bounded blocking queue implementation class is not empty and it's full, that means you cannot add elements in that particular blocking queue because already it's full. So what the implementation class will do, it will block that thread from performing that particular operation, in which case that particular thread will go into a blocked state. On the other hand, if you are trying to remove an element from a blocking queue and the blocking queue is empty, that particular thread that is trying to perform that operation, it will also be blocked. So this is what we mean, guys, by blocking queue. Like this definition that we just read here from Oracle actually means that. So as I have explained, guys, a blocking queue is an interface, and you will find this blocking queue inside java.util.concurrent package. Blocking queue, guys, does not accept null elements. So if you try to add an object that is not pointing to anything in memory, you will get a null point exception. And we also see that where can this be applied? It can be applied primarily for consumer producer queues. We will see that as we continue. So blocking queue, guys, it's thread safe. All the blocking queue implementation classes are thread safe. So blocking queue is just an implementation. And the benefit of blocking queue implementations is that as a developer, you don't have to be like, because we said that before you add an element, the blocking queue interface itself will check whether the blocking queue is full. In case of a bounded blocking queue, if it's full, it will block that thread. And if it's not full, it will allow. When you are removing, it will check whether it's empty. If it's not empty, it will allow the removal. But if it's empty, it will block. So as a developer, you don't worry about the technicalities of such a kind of checks. You don't need to do anything. The implementation classes do that for you. So this is a typical, not a typical, this is how a put method of the blocking queue is actually defined in the implementation class. So we see that all queuing methods achieve their effects atomically using internal locks or other forms of concurrency control. This explains the thread safety of the blocking queue. So we see that, as we explained in our previous slide, that it doesn't accept null values. If a value is null, then it will actually throw a null pointer exception. As you can see here, guys, this is a generic parameter. So we know that since Java 5, the collection framework was revamped, was built again to work with generics. Before that, everything here would be an object. But the problem with that was that you will need to explicitly cast this object to whatever object you're actually working on, which was quite burdensome to do. So generics, guys, gave us that flexibility of working with many types. As you can see, guys, here that you're obtaining an exclusive lock before you can execute this code. And then when you are done, you unlock the this log so that this code can be actually executed by another thread. So this code here is actually implementing the thread safety. So when you're talking about thread safety in Java, you're actually talking about logs. So that when you enter into a room and you are the only one allowed, you lock that room so that no one enters. So that's the analogy I can give you when it comes to multi-threading, especially the thread safety part of it. That you want this block of, you're actually trying to protect this block of code from being executed simultaneously in the case where many threads are trying to do this. And in the process of doing this, you are avoiding what we call race conditions. Because with race condition, guys, you end up being in a situation where data that you have is not consistent with what it needs to be. Because now many threads were executing that particular block of code simultaneously, and in the process, you end up having data that is not consistent. So this blocking queue, guys, has several methods, but we are not going to do all of them. We're only going to focus on the put method and the take method. But we can just describe these two. So the put method, guys, as you can see, it will insert an element into the queue. It will add an element into the queue, provided that queue is not full. So if the queue is full, a thread that is trying to add an element into the blocking queue will get blocked. But in the case of the add method, if the queue is full and the thread that is trying to add that element will be blocked, and this method will actually throw an illegal state exception to show you that you're trying to add an element into a non-empty queue. And then there are other methods, but we are not going to do all of them. So in the case of retrieving of elements or removing of elements, we have a method take. And this method, the way it works, it will try to check whether the blocking queue is empty before it can take an element. If it finds that the blocking queue is empty, the thread that is trying to take or retrieve the element will be blocked, because you can't take anything from an empty blocking queue. And a poll method, as you can see, guys, it has more parameters here, and obviously it provides more flexibility to the retrieval. As you see, it has timeout, which actually it doesn't. When you add this timeout, you don't want this method to retrieve the element immediately. It waits for a specific timeout, then it will try and retrieve the element. This is it. Other methods, guys, as defined from Oracle website are here. You can go online and actually do that. So as I said, guys, a blocking queue interface, it's just an interface defined inside the java.e2.concurrent package, and it has some implementation classes that comes with JDK that Oracle just gives out of the box for developers to use. So these implementation classes, we have array blocking queue, we have linked list blocking queue, we have delay blocking queue, priority, and synchronous queue. So all of these are implementation of the blocking queue interface. So, but today we're only gonna focus on this particular one, array blocking queue. So according to the definition, it says this one provides a fixed size array. So guys, blocking queue has types. Like I said before, we have a bounded queue and an unbounded queue. So a bounded queue, guys, has a fixed size. As you create the object here of type blocking queue, we see that it's bounded because now it has only four elements can be added into this blocking queue. And if four are there in the blocking queue, that means no other elements can be added until the list is not full. So if four is reached, that is a threshold. That means no elements can be added. And we also have an unbounded blocking queue, which doesn't have a fixed size. It can grow indefinitely. It will all depend on the scenario that you're actually tackling, or the problem that you're tackling. You might find that you need to use the bounded one. In some situations, you might find that you need to use the unbounded one. And finally, guys, I want us to look at just a mini, just a small application that we can do to 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 try and demonstrate how you can use a blocking queue. But as I have said, we're going to be using array blocking queue implementation class. So guys, I use FMB, and normally when you get to the bank, you see there is a ticket application that they use to service clients. So when you get to the branch, you don't immediately get inside the branch. There is someone waiting at the door. He or she will allow you depending on whether the number of people inside the branch have occupied all the chairs. In which case we can say whether there is still more space to allow more customers to come in or not. If there are no more there is no more space, then what you normally do, you wait outside. So we're gonna actually try and do that application. So customers arrive at the door, and only few customers are allowed inside. A bank can only allow 10 customers inside the branch at a time. All other customers wait outside. When a customer is serviced, he or she leaves, allowing new customers to get in. The process is repeated until all customers are serviced. So to do this particular application class, I'm gonna, like we said, blocking queue is used in producer consumer situation or context. So we're gonna have a customer entrance, which is a thread that will be adding elements into the queue, blocking queue, in which case here we're actually saying a thread or someone who is allowing customers inside the branch. And this particular one would be the service, the tellers that are actually helping customers according to the queries that they brought to the bank. And we have a bank as a class that we're going to use to test the application. We also have a customer to model the real customer. We're not going to have many properties here for a customer, like attributes. We're going to only work on one attribute, name, for that particular customer. So guys, without wasting much time, let's dig in and see how we can apply this blocking queue interface in the real world. So as I said, guys, we're gonna have a class called customer entrance. So let's start by creating that particular class. So this customer entrance, we have already agreed that it's going to be a producer. Sorry, let me just say producer, which is the class that is responsible for allowing customers into the branch. Then we have customer service, which is a class that we use um, to service customers as they arrive, as they get inside the branch. You can say it's a consumer. And then we also have a customer. We want to say customer entity, customer object. So this customer object, as we said, we're only gonna have a single attribute name. And let's generate getters and setters. Okay, let's start with the no argument constructor, getters and setters. Then we want to have a toString. I wish I was using Lombok to avoid this boilerplate code. Now, since I'm not in the enterprise edition of Java, I'm doing core Java, I need to do all that. We have the toString, we have the customer here. Okay. All right, so we are done with the customer class. Then what else do we need to do? Okay, so like I said, these are threads, guys. So here we're gonna be having something like this blocking queue. So this blocking queue will take a customer. So let's put it like this, and then we agreed that we're gonna be using array blocking queue. So we're gonna have how many? Okay, let's say we're gonna give this 3. Yeah, just 3. 4 is our capacity. That means we can only allow 4 customers into the branch at a time. And then I'm gonna put this here. Let me say private. This is encapsulation, guys. Blocking queue, so we should do it. So let me generate an argument constructor, and then okay, let me, since I'm a lazy programmer, I'm gonna copy this code to avoid wasting much time and put it here. So since these are threads, we're gonna implement a runnable interface. It has one method run that we're gonna override, and then we have to also do the same here, and then override that method. Okay, so now that we have done this, guys, we have to simulate customers coming into the branch inside this method. So I want us to only assume that the customers are gonna only have 6 customers coming in. In the real scenario or in the real world application, it will not be like that, obviously. So we can say here branch opened. So when the branch gets opened, that means the doors are opened, customers are allowed in. So for the purpose of generating customers, guys, I want us to just use a for loop to count customers as they come in, and then we're gonna just say customer, let me just say customer, then here plus I. So we're having customer 1. So here we can say customer equals to new customer name. So that means we are creating this customer, and then we have to now add this particular customer blocking queue inside the blocking queue. Alright, so okay, this method will throw interrupted exception. So we need to do something like this, because interrupted exception, guys, it's a checked exception. So we need to catch this exception here. And then after we add this customer, what we need to do here, we need to tell, to sort of show that the customer has been added. So we can say customer entered, okay, customer one entered branch. Enter, okay, we can say entered entered the door. Let me just say enter the door. Okay, that's fine. Okay, here we normally what I normally do, I just say print stack trace. Then when I'm done here, we need to indicate that maybe perhaps we are adding the last customer. So what we can do here, we can say put again new customer last, we can say last, we can say closed. That means the branch is closed. So we can just surround this with a catch block since it throws an exception. And then what we can do next now is to say branch closed, because branch was opened, obviously the branch needs to be closed. We are just simulating the branch, helping customers with their services that they want. And then here, guys, we're gonna simulate customers being helped now. So what we can do here, we can create we can declare a customer object, and obviously we need to use a try, because now we are going to deal with taking customers out of the queue. We know that it will obviously be throwing interrupted exception. So we know that if we have a checked exception, all subclasses of an exception class must have code that will potentially throw that particular exception that you have declared. So guys, since customers will be surfaced, like the time taken to service them will obviously differ. So I'm gonna use a random variable here to simulate that as well. So we're gonna say random equals to new random, so that we will be creating, giving an illusion that customers have been serviced with different times. So we say thread here dot sleep. I want us to just okay, let's not do this here, sorry. Let's rather say customer equals to BlockingQueue dot take. So we know that BlockingQueue will return us a custom. So what we can do here, we can say we want to continue taking customers as long as the customer is not closed. So what we can do here, we can do something like customer dot get name here dot equals ignore case. Yeah, so we can say closed here. So we can negate this because we want to continue looping as long as customer is not equals to that name. So what we can do now here, since we want to say we want the time to differ, and that we can say time taken to service a customer. So we can say this dot random dot next int. So we want to, if each customer we want to give them a maximum 2 seconds to be serviced. And then what we can do now, we can say thread.sleep, then we can say time taken. Then after that we can say customer got serviced, just to indicate that this customer was serviced. Then we have to update this customer object to take the next customer from the queue. This will continue to as long as there are customers in. Remember, while this thread is busy taking out customers from the queue, this thread is busy adding them, the things here. And then remember that here the blocking queue is basically allowing only 4. So that means what needs to happen is that when this is busy adding, when it finds that we have 4 already, it will be blocked. It will wait for this thread to remove an element before it can add another element. So what we can print out here, we can say branch closed. Then all customers serviced. This is what we can do here. All right. So okay, let me just move all these pages here. I hope, guys, you understand what I'm doing here, and all this time that I'm so we can even say here, we can even say serviced in plus time taken. We can say time taken divided by 1000 to say seconds, because 1 second, I think, does it 1 second is equals to 100 milliseconds, 1000 milliseconds, I think so. Yes, so it's gonna give us the seconds here, so we can put S here. So we're gonna say customer one serviced in this, and then we can say customer one serviced in this number of seconds. So here we can do this. Okay, let's just leave it like this. And then we have this guy. So now what we can do here, we can test since now these are runnable, which means they are threads, we can create a new thread by saying thread t1 equals to new thread. Then we can say, okay, before we even do that, let's create object of all those. So let's say customer entrance test equals to new customer entrance. So this customer entrance takes blocking queue, and we have customer service. Customer service also takes blocking queue, as we have seen here, the constructor that we have here, and this is it. So now normally this is not allowed, guys, what I'm doing here. So rather what I can do here is to remove this guy here. I can do this, sorry, rather than having it, this is tightly coupled code, we don't want that. So what we can do here, we can say random, we put it in here, and then we just declare it here also. We say private random, we declare it here, and then we pass it here as a parameter, and then we say random just random. This is a better way of doing it. And then we can pass it here also.
we have a loosely coupled code. So now that we have threads, we can basically execute these threads by saying t1 dot start, and then we can give this thread. We know that thread class also takes runnable. We can give it this. We can also do something like this, and then here take this guy, put it here. But this is not the proper way, because, or as you can see guys, when I'm coding, I'm always trying to run away from the use of new keyword. So Java also, when it comes to concurrency, it actually provided us with another interface that we can use to abstract that. It's executor service. So let's implement this executor. It has one method execute which takes runnable. So what we can do here, we can say new. This is what I normally like to do, and then we put this command here and we say start. So we want to abstract the the, the class that actually knows how to run a thread from the one that creates it. So here we can say executor service equals to new executor service. Now what we can do, we can say executor service dot execute what customer. Then we can also, since I'm a lazy programmer, I'm gonna copy this. So here we can say customer. Okay, customer entrance, customer service. Sorry, customer service. So now you see that since this customer entrance and customer service are runnables, so we can basically pass them to this execute method of the executor service, because it takes runnable as its input. And here we are running this thread. So guys, I hope this can deliver what we want. Let me just run it and see what it will give us. Let's just wait and see. Okay, it says customer service line 21. Okay, why is it doing that? Customer service line. Oh, I see, I see, I see. What is happening here? Something is fishy here. Yeah, I think I added it in the wrong class, so it has to come here rather. So this customer entrance, this needs to come here. No, I had a mistake that I made, and this needs to come here. Let me copy, since I'm a lazy programmer. I'm gonna copy this class and put it here. And then we don't need this here. We don't servicing cloud. We're not servicing customers yet. Yeah, now it should be able to work. I think. Let's run it and see. Stop. Okay, that's already running. Let's see. Because now this null pointer exception messed things up. Okay, it says customer one enter the door. Okay, let's see again. We said string customer one, first customer, and say BP pushed. Okay, and then here we say
Customer. Okay, I think something is wrong here. Yes, customer entrance, customer service. There you go. So it says customer one entered the door, branch closed. Now this is not the expected behavior. Let's see what went wrong here. Something might be wrong in here, I think. So this. So we say no, run this to next. Then we say thread.sleep. Then we say bp.take. Is it really needed to add some thread here? It should lots of service in 1 second. Something is wrong. Could it be that creating the random from another class? I don't think so. I'm just wondering. That could be the reason. Second. I don't know, but I don't believe that's the reason. Okay, let me just remove this here, take it back, and now program to the implementation. Okay, let me remove this thing here because now it will can see random here, so we can remove this. I don't know, but I don't think that's the reason. And then here we can just do this. I don't think that should be the reason why this is doing that. Customer one, branch closed. Customer one entered the door, branch closed. Customer two, it doesn't even have to print this branch closed many times. Branch closed. Oh my goodness. This should be outside, I think. Yeah, it should be outside of the for loop. Okay, so let me do this. I was actually okay. And say this. So now the problem is that this is in the for loop. So what we need to do, this code should execute after this has been taken out. So what needs to happen now, yeah, now it should be fine, because now we're adding this closed after all the customers have been serviced, and we say the customer is the branch is closed. Yeah, that was the reason. It should work now, guys, obviously. Yeah, this is the back end of the behavior that we need to see. In 1 second, 1 second, 1 second, 1 second, 1 second, and branch is closed. So as you can see, guys, here we started with branch opened, customer one entered door, 2, 3, and 5, and 4. So I don't know why it says it allows up to 5, because the expectation was that when we reach 4, the queue is full. No more people are allowed in unless a customer has been serviced. Only then we allow more customers. But as you can see here, when we reach 5, then another customers was allowed in. And no, sorry, we see that a customer was serviced, which means a new customer can come in. Then we see now another was allowed in. Then we see that the customer was serviced. Since now it was the last one, the branch got closed. And then we closed the door. And then now, since we have 1, 2, 3, 4 customers which are still inside, we have to service all of them before, then only after we can actually close branch, because all the customers have been serviced. Okay, so here let me do this. Let me say, as we service these customers, we are taking maybe 3, let's say we are taking 3 seconds. Just want to be sure that this number of we are servicing them with yeah, so this one take 2 seconds, as you can see, 1, 0 second, this one 1, this one 1, this one 2, this one 1, and all other customs. So as you can see, guys, this is the way BlockingQueue interface is actually implemented. So guys, thank you for watching. I hope you enjoyed this presentation, and please don't forget to subscribe. See you in the next video tutorial.